Good morning, good afternoon, and good evening to you, depending on where you are. Welcome to the Improve Your Workforce Planning with Decision Optimization. I'd like to mention a few things before we get started. If you have any questions that come up throughout the duration of the presentation, please feel free to type them into the chat window. Also, we'll leave a few minutes towards the end of the session to answer any questions that you may have. I'd like to introduce our speaker. Just like the Horizon Conference, which is a TM1 marathon that follows the sun for 24 hours, he's a true marathonist. Yeah, and also love Marshall guitar cubes along with TM1 cubes. He's also my colleague and the practice manager in the Netherlands. Ladies and gentlemen, Luc Cusiel.
Thank you very much for the introduction, Felipe. My name is Luc and I'm presenting to you live from Hilversum in the Netherlands, and we're going to talk about decision optimization. Well, in order to get the presentation started, let me just share my screen. All right, the topic of today is improving your workforce planning with decision optimization. So what will be the agenda for today? The topic that we will be covering is about how to propose a planning based on desired outcomes. Because we all do plans and we create lots of plans, but let's find a way on how to propose a planning based on desired outcomes. Let's first define the business problem. Then we're going to talk about the subject of decision optimization, what it is. We're going to discuss on how you design a solution. I'll do a little demonstration and I'll have a couple of takeaways. Let's first move to the business problem, how to solve the following puzzle. The business case that we're having deals with construction projects where we have demand of various activities at construction sites. These activities require workers with certain skills, and we need vehicles to transport the workers to the sites. Also, we need to assign the workers to the projects and vehicles. So there is an allocation or assignment problem that we're going to do. Most of the time, plannings are created in a manual way, and you need to understand about the skills of the people and all kinds of soft things in order to create a planning. But in this case, we want to create a planning using optimization, which is optimized vehicle utilization while meeting the demand. All right. Decision optimization. So what is decision optimization? That is the way we solve like business problems that I described in the previous slides. It belongs to the field of the operations research. So there's studies at university where you can, learn about all the details of operations research. It's basically about applying mathematics to business problems. That is what we're going to do. And one of the main areas over there is linear programming. So linear programming is an optimization technique where we consider practical constraints. And within those constraints, we want to maximize or minimize some kind of objective. And we do the optimization with a method called the simplex method. That is an optimization routine. So in the figure on the right-hand side, what we are seeing is a couple of constraints depicted as purple lines. And the constraints, they make a set of feasible solution, which is like the yellowish area. And the objective function is represented by the orange line. And we want to like maximize something across this line. So the optimal solution is always belonging to an edge, or also called a vertex of this feasible solution. And the simplex method is helping us out finding the optimum value of the objective function. So that is the field of operations research. We also call it decision optimization, applying mathematics to business problems. So let's move on. In order to solve this business problem, what you need to do is you need to create a linear program in order to be optimized. And that consists of a couple of components. The first component is an objective. And in this case, we have a combined objective, which is for the workers, we are going to maximize the demand fulfillment. For the vehicles, we're going to minimize the number of spare seats left in our vehicles. The constraints that we're going to implement in this solution is that the number of workers needs to be smaller than or equal to the demand that we have at the various construction sites. A worker needs to be assigned to one site and one task. A worker skill needs to match the task that needs to be executed. And the number of planned workers needs to equal to the number of required seats in order to determine which vehicles we need with which capacity. And the number of required seats needs to be smaller than or equal to the vehicle capacity. And the final constraint is that a vehicle can only be assigned to one site at a given day. If we move to the right-hand side, we are arriving at the decision variables. That is the most important part of the planning. So the decision variables is like all the touch point we have with the planning. All the possible options of the planning is represented by decision variables. In this case, we have binary variables and continuous variables. Binary variables are all the combinations between sites, the workers, and the skills. So that is one part of the optimization. The second one is all combinations of a site, worker, and a vehicle. Then we move on with all sites and vehicle combinations and all sites and worker combinations. And finally, all worker vehicle combinations. So that ties everything together. Those are all like the planning decision options that we have that we want to optimize. The variables are binary. So if the value is a 1, it means that is a valid combination, which means that person A is assigned to project B and vehicle C. That's how it works. Then finally, we have a couple of continuous variables, which are the number of workers per site, the number of seats per site, and the total vehicle capacity per site. And we need those continuous variables in order to determine the value of the objective function. So those are the ingredients of a linear program. So let's move on with the solution. Definitely, we need software in order to get this running. We need a planning model. And we're going to use our favorite T1 functional database in order to model the planning application. For the user experience, we're going to use Applico UX. For system integration, we're going to use T1 Pi and of course Python. As a linear program modeler, we're going to use Pulp, which is an open source Python library that you can use in order to set all the decision variables and the stuff that I explained in the previous slides. And finally, we need a solver that solves the linear program and finds the optimum solution. That can be Cplex, or it can be other solver like CBC, which is an open source solver. So now that we have like all the cocktail in place of the stuff that we need in order to get things going, we need the solution design. And this solution design is represented with a model architecture. On the left-hand side, we have the input. On the right-hand side, we have the output. As an input, we have the demand. So what is the number of workers with which skills we need at the construction sites? We have a skills matrix where a worker can have one or multiple skills. And the more skills he has, the more different tasks he can be assigned to. We have vehicle attributes where we mainly store the capacity of the vehicle. On the right-hand side, we have the planning that is generated. The planning means a combination of worker, project, vehicle, and task. That's what we have. So what do we need to do in order to generate the planning? That is run a Python script using T1 Pi and this Pulp library. We're going to execute T1 MBX queries. And one of my other colleagues of the Dutch office has given or is already given a presentation about MDX queries, Martine Giovanni. Second thing that we need to do is to convert this data into data frames and dictionaries, which are structures that can be easily manipulated and accessed in Python script. Third step is to create the linear program with all the ingredients that I explained. You need to define the decision variables, objective, and the constraints. And then we proceed with solving the linear program and mapping the output to a cell set and write that back to tier 1, to the planning cube. That's how the setup is. So show me the money. Let's move on to the demonstration. I'll log on. To the application. Let me just set the screen size a little bit bigger. So what do we have here? This is a screen where a big part of the screen is the demand input. So in the columns, we have the various dates. In the rows, we have the activities. And what is plotted over here is the demand for a specific activity at a specific date. So we have various versions, version 1, version 2, but also we have various projects. In this case, we have the renovation of the Big Ben, an extra wing in Buckingham Palace, and we're going to build Arundel Castle. Also, you're able to type in this information manually, but you're also able to upload the information from Excel, and you're able to copy versions by using the version copy screen that is underneath this button. So what are we seeing here? So let's just check our planning for all projects all together. So what we see in the bottom part of the screen, that is representing the view of the capacity, demand, and planning overview. What we see in the purple line is the number of workers that we have available, which is our capacity. So we have 20 workers available throughout the year. And there's a couple of interesting lines over here. So the orange line is our demand. So that is what the demand is at the construction sites at a certain moment in time. But what we are seeing is that it is not fully aligned with what has been planned. And that is interesting because we have 20 workers available, but still we're not able to plan like all our activities. So how is that possible? And that relates to the skills matrix, because the skills matrix determines what a person actually can do or is able to do without messing up, obviously, at a site. So let's check some details. So if we move to structural work, what we see here is quite interesting. So we have 4 persons who are able to do structural work. But at this specific moment in time, we have demand of 6 workers. So we're unable to meet that unless we're going to hire a specific person, a temporary worker on this day. So that's quite interesting. So let's move to set work. Over there, the same thing. Also, we have some demand that is more than our capacity. Let's move to installation work. So this is interesting because what we have is, well, everything is below the maximum capacity that we have, but in this specific date, it's only possible to plan 1 person, which means that this person or the other person that is able to do this activity is doing another activity on that day. So you see that the jacket is a little bit too tight concerning skills. So let's take a look at that. So as a skills matrix, what do we have is on the left-hand side, we have our employees. So for example, we have Tony Yoni, who's able to do structural work, set work, and carpentry work. So we have in total 20 employees, and in total they have 29 skills. So about half of our employees is only able to do one task. So that does not seem to be like very efficient. So let's move on and see what further ingredients we have. So let's go to our personnel screen. So this is like basically the same screen, but with some more attributes, because we have their addresses as well. And we could also like optimize the route from the worker's address to the construction site address. But that will not be covered today. Well, let's move to the vehicles to see what we have over here. Yeah, this is where we have like license numbers, the number of seats that we have available. And in the bottom part, we have our vehicle utilization. So what we are seeing, so we had a little bit of mismatch with our skills metrics in order to meet the demand. But what we are seeing over here is that we have more than enough vehicles available. So the occupation is most of the time, if a vehicle is selected for a specific site, it is utilized for 100%, but not all vehicles are utilized. So that is not like very optimal, but that's the case. So we could get rid of some of the vehicles if the demand remains like this. So yeah, what to do next? Let's just move to version 2. And in version 2, I did an optimization, another optimization. I played a little bit around with the skills metrics. And what we are seeing here is like the ideal situation is where the demand equals planning, and there's no mismatch between the demand and planning. So what was required in order to do this, that's something that we need to analyze using the version comparison screen. So if we move to the version comparison screen, what we see here is that I needed to add structural work as a skill to 4 more workers. And I needed to add the insulation skill to 1 more worker and the brickwork skill to 1 more worker. Also, finally, I needed to add 1 more, the painting outdoor skill to 1 more worker in order to make it work. So what is then the final outcome? If we move to the personnel, so version 2, so now we have 36, and what we see, there's still persons who have 1 skill, but the majority of workers now have 2 skills or more available. So now, the final screen, where is our planning? Well, definitely in our planning screen. And actually this screen, a lot of information is depicted, because what we see over here, the right-hand side, is that we have a big scroll bar. So this is like the entire planning of the year, where we have all the combinations between a worker, an activity that he needs to do, a vehicle that he needs to travel with, and the project he is using. So if we want to zoom in to one specific project, for example, we clear it here and we check, for example, the Big Ben renovation. Then we have the entire planning for the Big Ben renovation project. So now what about optimization? Because before you run this optimization, the screen is blank. So there's no planning available. From within this screen, you're able to run the optimization by selecting a month or a date. You're able to run CPLEX, in this case, the optimization algorithm that is executing all the tasks that I described earlier in this presentation. So that is generating all of these planning details. So this is like all there is to mention, well, considering the demonstration. Let's now move back to the PowerPoint. And let's discuss a couple of takeaways. Because in my opinion, there's a world out there to optimize, so give it a try. Because decision optimization is really a natural extension of a planning application, and TM1Pi is the enabler. TM1Pi allows you to very easily integrate this into a solution that is built with TM1 in Applico UX. There's only one thing. Experience is required in order to set up the linear program, because operations research is studies at university, so it requires a skilled worker who's able to set up the program. But once that's set up, ready to go. Also, there's additional business value. It's not about just the optimization itself, which will already bring return on investment. But what you can also do is like do sensitivity impact, gain more insight in your drivers by running these multiple scenarios, as what we've seen in this demonstration. It also allows you to make investment decisions, for example, to decide in which vehicles to invest or buy or sell vehicles. That is a decision that can be taken. But also in terms of human resource perspective, which skill combinations of workers are relevant. And in that way, we can more efficiently execute the projects at the construction sites. So this concludes my presentation. Let's move on to the Q&A section. Are there any questions?
Yes, there are some questions. Thank you very much for your presentation, Luke. So I'd like to know if this open source solver is also good for decision optimization as the Cplex is. And,
Yeah.
if you can tell me like the difference between them.
That's a good question. Well, of course, you can start using open source solvers. That's like totally fine. There's only one thing, because most open source solvers do not scale up for the enterprise, and Cplex is really an enterprise solution and is solving linear programs and bigger linear programs faster than an open source solution. That's why it's like an enterprise grade solution. But to start off with, you can use it, but you can also start using the open source solver first and then move to Cplex, because you can still use the pulp library, which is the linear program modeler, and you do not need to throw away what you've created before. You just change the solver and you're done, and the linear program stays the same.
Fantastic.
Cool.
Another question that we received here is, can we use decision optimization for cost allocation or investment allocation?
Oh yes, there's like many applications, and like what we did here is some kind of human resources allocation. So all business problems related to allocation can be solved using a linear program, and hence, with mathematical optimization. Good.
And the last question here we received is this Simplex some kind of a technology that comes with the Cplex?
Now, the Simplex method is, a generic algorithm, a generic method that you can learn on university as well, but it has been implemented in Cplex. So most of the solvers are using the Simplex method or the variation of the Simplex method in order to come to a feasible solution. So what is this Cplex method is doing? So remember the feasible solution area.
Yes.
With the boundaries of all the constraints. It is traveling like all the corners or all the vertices of that feasible solution in order to find its optimal solution. And you can, like if you study the textbooks, you learn how this algorithm can be implemented. So
Really
that
cool.
is like a universal algorithm.
Universe.
Yeah.
Okay, thank you very much. Well, thank you all for attending this session. Please remember to provide feedback. The link is available on the presentation page, and we're going to give a prize for you that give a feedback to us. It might be a Nintendo Switch, which is really cool.
Yeah, and you can also win a candy bar if you can name the bands of all of the guitar players that were listed as workers.
Yeah, they don't build wood structures, right? Only stone and rock, I suppose.
Exactly.
On the schedule up next, we have implementing TM1 with small smart teams with Mark Weller, and also modern data exchange strategies with TM1 Pi with Marius Wirtz. Okay, so don't forget to give your feedback to this session and to attend the next sessions as well. Thank you very much.
Thank you very much.